Hey guys, so in this video I wanted to go through lesson 2. So factoring quadratic equations where a equals 1. Remembering that our a is referencing it to our standard form of our quadratics. Y equals ax squared plus bx plus c. So that a is that coefficient of x squared. First step is to factor a trinomial means, and what trinomials means is that there are 3 terms. Means to write it as the product of 2 binomials, which is going to include 2 terms. We are first going to check if there's a GCF, or greatest common factor. Now you may have been taught different ways of how to factor in Math 1. The easiest way, in my opinion, is the big X method. What do I mean by this? Is that you're going to have a big X, you're going to have your B coefficient or your B number, then you're going to have your C constant, and then you're going to find what multiplies, 2 numbers that multiply to get to your C, but also adds to get you your B. So let's do an example. For number 1, our A is the understood 1, our B is 6, and our C is 8. Is there a greatest common factor? No, there is not. There is not a greatest common factor other than 1 that can go into x squared, 6x, and 8. So then we're going to use our B number and our C number to find our magic numbers that are going to multiply to give us our C, but also add to give us our B. So our big X, our B is going to go off to the left, and our C is going to go off to the right. Now, if you can go ahead and see your magic numbers, that is fine. If you cannot, you can create a table. Start with 1. 1 can go into any number. 1 times what can give us 8? Well, 8. Now, if these were our magic numbers, they would have to add or subtract to give us 6. Well, that's not the case. We can't do 1 plus 8 gives us 6, or 1 minus 8 to give us 6. So let's keep going. The next number is 2. Can 2 go into 8 evenly? Yes. 2 times 4 is 8. Can we add and subtract 2 and 4 to get to 6? Yes. So those are our magic numbers. 2 and 4. We can multiply 2 and 4 to give us 8. We can also have 2 plus 4 to give us 6. So what do we do with these magic numbers? Well, we're going to put them in parentheses for our factored form. We have a positive 2, so we have plus 2, and we have a positive 4, so we have plus 4. And then what was the variable that was in our original expression? The variable that was in our original expression was x, so that is where our variable is coming from. And that would be our factored form. Pause the video and try number 2. For number 2, we have a that is 1, b value of -3, and a c value of 2. There is no greatest common factor in this case other than 1, and we're not worried about the 1. And we're going to use our big X method again. -3 on the left, 2 as our c on the right, And we're asking ourselves what times what gives us 2, but can also add and subtract to give us negative 3. Again, if you cannot see the magic numbers, you can start with a table. Smallest number that can go into 2 is 1. 1 times 2 is 2. Can we add and subtract 1 and 2 to get to negative 3? Yes. So those are our magic numbers. Now, 1 times 2 gives us 2, but if we do 1 plus 2, that does not give us negative 3 that we want. So we gotta kind of switch things around. So what can we do to 1 and 2 to make it negative 3, keeping the addition in between? Well, if we change 1 to negative, negative 1 plus 2 doesn't give us negative 3. So let's see if we change both of them to negative. Negative 1 plus negative 2 does give us negative 3, so that checks out. Well, if we change the magic numbers to both negative, multiplication also represents that. Negative 1 times negative 2 does give us positive 2. Negative times a negative is a positive. So our magic numbers are negative 1 and negative 2. So we have our 2 parentheses. We have a negative 1, so we have subtract 1. Negative 2, so subtract 2. And the variable that we were factoring was x. So that would be our factor form for number 2. Now, what if we did have a greatest common factor involved? So let's go to number 9. Number 9 gives us an example of our a not being 2, or not being 1. So looking at the terms 2x squared, negative 6x, and negative 140, what is our greatest common factor? It is 2. It is not 2x because the negative 140 does not have an x involved. So, kind of what we learned in lesson 1, if we have a greatest common factor and we are factoring, we're going to factor out or divide out our greatest common factor of all of our terms. So we started with 2x squared minus 6x minus 140. Now we're going to take our 2 as our greatest common factor and put it on the outside. So we have 2x squared divided by our greatest common factor, and we're left with x squared. Then our next term was negative 6x, and we are dividing it by our greatest common factor, which is 2, and we get negative 3x. And it's negative, so we have subtract in our expression. And then lastly, we have negative 140, and we have to divide it by our greatest common factor that we're taking out and putting it in front, and we get negative 70. So this is our new expression, 2 times x squared minus 3x minus 70. So to put it in factor form, we've got to factor out this x squared minus 3x minus 70. Granted that we're always going to have that greatest common factor out front. So that 2 is going to stay. So for our expression, our new expression, x squared minus 3x minus 70. Our b is negative 3, and our c is negative 70. So our b comes off to the left, our c comes off to the right, and we're looking for 2 numbers that multiply to give us negative 70, and also add to give us negative 3. So you can create your little table. Start with number 1 always. What 1 times what gives you 70? 70. 2 times what gives you 70? That's 35. 3 cannot go into 70 evenly. What do I mean by evenly? I mean if you do 70 divided by 3, it will give you a fraction. Same thing with 4. 4 cannot go into 70 evenly. 5 can go into 70 evenly. 5 times 14. 70 divided by 6 would give you a fraction, so you're not worried about that one. Then you go on to 7. 7 times 10. Now, out of all of these factors, what two numbers can also add or subtract to give you -3? 7 and 10. So let's see if we need to adjust these magic numbers. Well, 7 times 10 doesn't give us -70. 7 plus 10 also doesn't give us -3. But let's see which one we need to make negative to make all of this true. To get -70, only one of them needs to be negative. To have our -3, our biggest number needs to be negative. So 7 plus -10 gives us -3. That's what we want. If we make our 10 negative, 7 times -10 does give us -70. So our 10 needs to be negative. So what does this mean? If it was simply just our expression of x squared minus 3x minus 70, our factor form would be x plus 7 because it's positive times x minus 10 because it's negative. But it is not simply just x plus 7 times x minus 10. We did have a greatest common factor, so our answer is 2 times those two parentheses. So there is our factored form of number 9. Again, this is just helping you to see some examples so you can come into class and ask questions.